Good morning, everyone. Vanakkam. My name is Vinoth Kumar. I'm working as a chief architect in Visa. A couple of years before, I got introduced into the blockchain, Bitcoin, and Ethereum technology. It was one of the R&D project I started, and then my interest was, all the time, 2 decades of experience. I was in the finance, pricing, and payment technologies, and that's how my interest started into the blockchain and Ethereum and the cryptocurrencies. So high level, these are things I'm planning to cover. I do give a training. I'm part of the DAP Academy, and most of the slides I pull from there and then I put it here. It's very short period of time, so short time. I'm trying to cover very high level Bitcoin, blockchain, cryptocurrency, and the Ethereum technologies. So high level, these are things I'm planning to cover. How the money is created, the transformation, what is a Bitcoin, buy and send Bitcoin, what is the blockchain, how does the Bitcoin network work, use cases, and the cryptocurrencies, Ethereum interaction, and another blockchain. To start with, how many of them know Bitcoin? How many of them owns Bitcoin today in this crowd? Just wanted to see the mix of the crowd. Okay, so pretty much everybody knows what is a wallet, what is a Bitcoin, how to buy a Bitcoin, how to sell a Bitcoin, looks like, right? Okay. To start with, right, how the money is getting created, right? I just took United States, how the money generation or creation happened. Federal Reserve created, basically Federal Reserve created 1918, right? In the creation process, basically government issues the treasury bonds, and the federal prints the money and buy the treasury bonds, right? Government now can spend that money, and taxpayers will give back the money. This is how the generation and then the cycle, money cycle happens. So obviously there will be a total supply, money supply, right? How much money exists, and let's look at the United States. This information is available in the money supply side, right? So this is the historical money supply up to January 2018. The data is available, right? So you can clearly see the graph, right? And again, I'm just showing here how the money supply happens, right? Now the transformation, right? Initially, the barter system, right? It's basically the apple to chicken. It's a very bad deal, right? And then the gold coins came into picture. That's basically the intermediate money kind of thing, where using the gold coin, people will buy the utility and then they sell the utility. Then fiat money came into picture, right? And then the digital representation, where the banks and mediator comes, and then the money associated with the account number, right? And then the digital representation of money, that is the corporate tokens using the credit card, debit card, all the stuff. There is a number, there is a numbers associated with that, right? And then the Bitcoin era, right? Up to the 5 corporate tokens, it's all centralized management. Now the Bitcoin, we are in the Bitcoin era, right? It's a decentralized money, digital money, right? This is how the money transformation happens. Now, what is a Bitcoin, right? And who owns a Bitcoin? Again, Bitcoin is a digital currency. It's an electronic cash system, right? Bitcoin uses the peer-to-peer technology, right? There is no central authority or banks. It's an open source, right? The Bitcoin was designed by the Satoshi Nakamoto. Nobody knows who that person is. Only thing is we know the paper. The white paper has the Bitcoin and blockchain details. Using that, people developed or enhanced using the specification, people developed the Bitcoin and the blockchain. And still he owns some Bitcoins and that nobody claims. So In 2008, as I said, like white paper, he released white paper right after the financial crisis. It's basically a peer-to-peer electronic cash system. The term, as I said, like the term blockchain was coined by the Satoshi in his paper. So 2009, the first block mined. I'll cover what is a block, what is a chain, and how the mining is happened, and what is a private key, public key in the upcoming slides. Everybody knows World Wide Web and peer-to-peer, right? So World Wide Web, central computer, all the clients will connect to the central location, right? If the central location fails, all client will cannot connect, right? The peer-to-peer, this technology is not new actually, right? Everybody knows Napster, music sharing network, and the BitTorrent. Everybody knows that, like the movies and other stuff share using the BitTorrent. So this because of the copyrights and other details, this two network is no longer available, or it's very minimally used. Again, what I'm trying to say here is like the peer-to-peer technology. This is not new. This is already available. The Napster, the BitTorrent, those guys are used before in the technology, right? Next, the units of Bitcoin, right? Basically, 8 decimal equal to 1 Satoshi, right? This is the Satoshi converter, right? And then it up to 1 Bitcoin equal to like 10 million Satoshi. So again, 1 millibaht is equal to 0.001 Bitcoin. That's equal to like approximately $15. These are the units of Bitcoin. And Bitcoin total supply, everybody knows that in the 21 million, and we are about in 18 million. And once it reaches the maximum, like we cannot buy and sell, right? We can buy and sell, but we cannot have more, right? In this graph, I'm showing how the inflation versus the time, right? What happens after all the 21 million Bitcoins mined, right? Bitcoin is a gold in many ways, right? Like gold, Bitcoin cannot simply be created arbitrarily, right? Gold must be mined out of the ground, right? Similar to that, Bitcoin also needs to be mined in the digital means. And I'm just comparing against the money supply versus the Bitcoin, right? In the left-hand side graph, basically 10 years of money supply. It gradually increased and 2000 and up to 2015 this graph shows. I'm just comparing against the last 10 months or 15 months Bitcoin price. Coincidentally, it is matching the graph, right? And I want to just show the Bitcoin price and then the total market cap and the daily transaction and the money supply. So, and everybody knows this ledger, right? Accounting. Ledger meaning like if any banks, any accounting comes, ledger will comes into picture, right? And at the end it should tally, right? And banks and Bitcoins. Basically, banks is how the bank works is bank uses the centralized ledger, also known as the general ledger, contains the account recording transaction to the company assets, liabilities, and the related entries, right? All the accounts related or transaction related stuff will be available in the ledger, and this is within the bank, right? If multiple banks comes into picture, then clearing house will comes into picture. They have the centralized ledger. Still, there's a ledger maintenance will happen. In the distributed side, everybody has their own copy of the ledger, and all the entries will be maintained within the ledger, and the ledger is shared. That's where the distributed ledger. Again, Bitcoin uses the same technology, ledger technology behind the scene. It's a centralized from distributed ledger, and it shared within all the nodes. Here, this is the difference between the centralized, decentralized, and distributed networks. Centralized systems, we all know it's all central point. All the nodes will connect to the central system, right? If the central system fails, then all the nodes will lose the copy of the ledger, right? And the decentralized system, right, where like multiple server nodes will be available, and the edge nodes will be connected to either to the central nodes or the edge nodes. And the distributed system, it's a peer-to-peer. Everybody connects each other, and node can act as a server as well as the client, right? Here, red dots denotes the individual nodes or terminals, right? This is a difference between the centralized, decentralized, and the distributed network. In this upcoming session, like I'm planning to cover the Binance and Bitcoin, right? In order to send the Binance, and like we need to have the public and private keys and then the encryption. It's very similar to the email account, right? Public key is equivalent to the account number. Private key equivalent to the login and password, right? I'm just taking the email example, right? Here, hello Alice is the data, and using the Bob's public key, we are trying to encrypt here. This is the data we'll be getting, right? And then when we decrypt the data, the same. I mean, using the private key, we can get the original data. This is same exactly the transaction side of it using, right? So public key is equivalent to the account number. That is the one we'll be sharing within the network, right? Private key is something like secret. It's equivalent to the password that kept within the wallet, right? Again, the transaction, right? So as I said, everybody knows that a wallet is the one holds the Bitcoin. It's similar to our wallet. If you lose the private key, then you cannot retrieve or you cannot reclaim the Bitcoin, right? So Sally creates a Bitcoin wallet. So Sally gets the private key as well as the public key. Public key is the one shared with others, right? Using the public key, the transaction will happen, right? Sally gives the Jim her public key. Using the public key, Jim can open his wallet, send a Bitcoin to Sally key, right? This is how the transaction happens, right? And Sally now has a one Bitcoin in her wallet. Using her private key, they can open the transaction and they can see in her wallet. So this is how the public and private key used in the Bitcoin or the wallet side. And I'm just showing here the wallet, right? Wallet transaction. So it has a date. It's very similar to our ledger, right? It has a wallet. It has a to and from, where it is coming from, and then amount, and then the balance. In Bitcoin, either you can share the public address, or using the QR code, we can share. And the Coinbase, right? If you see your Coinbase account, you'll be seeing the public key as well as the QR code. Either QR code or the public key can be shared to the others. So using the public key only, the transaction will happen in the network. Again, how do we do the name some exchanges, right? So how do we buy a Bitcoin? Everybody knows that Coinbase is one of the most famous or popular way to buy and sell Bitcoin, and also it supports other cryptocurrencies like Ethereum, Litecoin, right? Easy to buy. Only main thing is like the private key is held in the exchange in the Coinbase, right? GDAX, Bittrex, Polynex, Binance, Rakan, Gox. These are the exchanges people use today, right? Everybody knows that whoever has the Bitcoin, right, knows that. And there are other cryptocurrencies also we can buy. Again, there is an intermediate currency, Ethereum. Using the Ether, we can buy the other currencies and then keep it in your wallet. Best way to storing Bitcoin, right? Yes, your own wallet offline. That is the best one. Yeah, some people has they'll store it in the exchange itself. But the suggestion is if you have a Bitcoin, store it in your own wallet offline, right? And there are hardware wallet available, right? Do not keep it on exchanges. That's what people will say. Yeah, again, keep the private key very, very safe. Again, too safe also, you will lose it, right? So you need to be like very careful about the private key, right? So yeah, I mean, obviously, like forget about the episodes, right? There are a few ways to store private key, right? QR code hidden somewhere, right? Write it on the paper, save it in the safe or bank wallet, right? Put it in a text file, encrypt heavily, store it in the cloud. As I said, if you lose your private key, you'll lose your coins. It's very similar to our wallet, right? If you lose it, that's it. Again, it's a one-way. Cannot reverse the transaction. How Bitcoin is giving the trust, right? Cannot reverse the transaction, right? Again, it has own pros and cons. Cannot be forced to pay, right? And yeah, every transaction is A is transferring to B. There will be obviously this fee, right? It's very, very small, rule 1, right? And older coins have the less fees, and the smaller transaction requires the less fees. So these are the rules they follow when we do the transfer and the fees. And yeah, who pays the fees? Yeah, obviously, like when the initiator initiate the transaction, then obviously he needs to pay the fee, right? It's very, very minimal compared to the current transfer fee, right? How it is calculated? It's based on the certain KB, right? How does the price change? It's based on the merchants versus the customer. Again, the P2B base, it's different. Person to person space, it's very, very, very minimal. But the thumb of rule is all 3 rules used while calculating the fees. Some fun fact, right? In 2004, approximately 200,000 transactions, approximately like $114 million at this time. Now it's like 3.6 billion, right? Again, what is blocks? These are the terms used. Are used in the blockchain, right? Block is basically it contains like set of transactions, and it will have the previous block will have the one number, the block number, and it will have the reference to the previous block. It's very similar to the linked list, right? One after another. It's basically I took from the live transaction. I created a block. If you see here, let's take a block 51. It has the previous block reference, and it has set of transaction. I do have one demo project where it shows like a blockchain distributed and then Coinbase. Probably if time permits, I'll show that as well. Again, in the all the blocks in the blockchain, it's available in the Explorer, right? Blockchain.info will have all the latest blocks available, and how much time it takes to create a new block, and how many number of transaction and total amounts. So every block has this information, and the size and the weight, right? The confirmations. Yeah, obviously the double spending is one of the major thing, right? If a person is trying to send money, then in between somebody else, other transaction happens, then we have to prevent the double spending, right? And in case of blockchain split, each transaction strengthens the previous block exponentially, right? Yeah, in the cryptocurrency, there is called like anonymous and pseudonymous, right? Basically, the meaning here is like, you can see all the transaction, all the blocks, right? And you just don't know who owns which account, because with the public key, we cannot figure out like who is that person, right? And you can verify if someone claims or someone owns an account, right? That is possible. Basically, the pseudonymous, what I'm trying to say here is, I can't identify you, but I can definitely single you out, right? That's how the transaction cryptocurrency works. Why not the regular database? What is the major difference between the traditional database between the blockchain database, right? A database can be manipulated, right? And it controlled centrally. That's one of the main thing, right? and it is hackable. I'm just showing the difference between the blockchain and the traditional database, right? The blockchain database only insert operation, right? Cannot use update or we cannot delete it, we cannot reverse it, right? We can do another transaction, but we cannot delete it. And the replication here, each nodes will have the full copy of the ledger. Basically, the full replication of block on each peer participating in the network. But in the traditional database, it's either it's a master slave or the multi-master, right? Either a single database or master slave or the multi-master, right? Here consensus. Here in the traditional database model, we all know it's a two-phase commit, right? And a distributed transaction. But in the blockchain world, majority of the peers will agree outcome of the transaction. Otherwise, the transaction will not get committed. The transaction will not get into the block, right? And invariance. Anybody can validate the transaction across the network. That's one of the main things, right? And here in the traditional database world, it's only the integration constraints. Whatever constraint you define at the table level or the at the block level, database level, those are the constraints we have, right? And again, I just wanted to show the blockchain innovation journey. I took it from the Harvard Business Review. So 2008, yeah, Santosh Nakamura, they introduced the paper. Basically, that's where the Bitcoin name coined out. And first implementation of Bitcoin was the blockchain, right? And then beyond that, not only the money, the smart contracts. They introduced the smart contracts. That's basically physical contracts translated to the computer code. That's where all the other cryptocurrency came in, right? And then the third is the most, innovative one, smart contract, right? And the blockchain 2.0 system. Now people are concentrating on the efficiency scaling. Now the main problem here is like per second in the blockchain world, it's like 12 to 15 transactions is happening. Ethereum world, they are improving the efficiency. Now the IOTA and the new coins and all, they are doing like 80 transactions per second. Still, they're not able to concentrate on the typical network, right? Visa per second, like we process like 12,000 transactions. So now people are more concentrating on the efficiency and the scaling. That's where we are. So how does the Bitcoin work? Again, the systems of the fault tolerance. If one node goes down, automatically other node will pick it up, and then once the node come up, it will take the transaction from the other node or the ledger from the other node, right? And I was talking about the mining before. So mining at a glance, right? Basically, mining bundle transaction in a block. Verify if the transaction is valid. This is how when the transaction gets committed, miner will pick the transaction. It will check, verify transaction is valid or not, and then select the header, most recent block, insert into the new block as a hash, and it's get replicated to the other blocks as well, other peers as well. And again, here to solve the proof of work problem, miner needs to work hard to verify the transaction. Right. When the solution is found, the new block is added to the local blockchain and it propagated to the network. Right. It's like this. And the proof of work, when teacher assigns a problem to the students, everybody will pick the problem and then try to solve it. Whoever solves first, that person will commit it, and other persons will receive it. That's how it works. But the problem with the proof of work is everybody has to work. Miner has to work hard. So a lot of wastage of resources because first person finish the problem, rest of them also trying to solve it because they're trying to complete. But that the work will not get committed. Again, nodes and miners in the network. Yeah, a node can be a node. They can just participate, and the node can be a miner as well. They can pick up the transaction. They can do the validation and verification work. Again, think about the BitTorrent, right? Sharing your music. You can share a video, right? At the same time, you can pick up the video from the other node, and we can show that. Another fun fact, right? A combination of 500 most powerful computer together, the Bitcoin, it's still like 7,500 more powerful, right? And there are like two main protocols or main proof of work today. Bitcoin, the blockchain world, we are using the proof of work, and the next version will have the proof of stake. The proof of work is the requirement defined to the expensive computer calculation called mining, and proof of stake is the creator of the new block choose and the determined way based on the wealth and define the stack. That's the main difference between the work and stake. Use cases on the Bitcoin blockchain world, mainly the remittances, right? Send money overseas instantly, and no filling tons of paperwork, no heavy fees, and microtransaction, right? Send the fraction of a penny, and IoT devices, gas dispense. These are all the blockchain main Bitcoin use cases. And on the cryptocurrencies ICOs, there are in the project ecosystem, there are currencies, there are developer tools, sovereignty, fintech, almost all the industries verticals using this. Again, different bitcoins. Bitcoin has been forked into 3 different other coins: BTC, Bitcoin Cash, Bitcoin 2x, and Bitcoin Gold, and BTC versus XBT. Basically, BTC is often called the Bitcoin community. BT is basically the country code of the Bhutan, and X code reflects the currency that are used in the internationally, right? So these are the different varieties of Bitcoins, right? And cryptocurrencies. There is a Litecoin, there is a Bitcoin Cash, Monero, Dash. I just showed top 5 or 6 cryptocurrencies. And ICOs are not IPOs, initial coin offerings, right? And these are the top ICOs for the last month, I can say. Augur, Civic, Basic Attention Token. This is one of the digital advertising. It's very, very, very famous. Whoever has created the Firefox, that person is doing this, and it's very famous in the Ethereum blockchain now. The first ICO is on Ethereum basically. The first ICO on the apart from the Bitcoin, that's called Ethereum. Again, Ethereum uses the Solidity programming. In the traditional Bitcoin blockchain, we can do only the money transfer, but Ethereum has Solidity programming, all the paperwork and the unregulated, right? Not limited to the accelerated investors, and not limited to the geographical area. Instantly receive your investment token, right? Those are the ICOs on the Ethereum, right? ICO had a wave earlier, a lot of blind investing, high profits. We all know that. Probably Arvind will cover more on how to invest. I mean, what are the investing models, investing methodologies or models we can use. It just needed a white paper, and cracking the fake ICOs. People became more aware, right? And blockchains are protocols like HTTP, TCP/IP, right? Can be used for transferring property, good against fraud, right? Examples of blockchain: Ethereum, NEM, Neo, IOTA. These are some of the examples of blockchains. And just wanted to show a high level private versus the public blockchain, right? Public blockchain, Bitcoin, Ethereum, etc. Private blockchain occur, distributed ledger. I think Mohan will cover more on the private blockchain side of it. Coda, Hyperledger, Coda. These are the private blockchains. Again, in the Ethereum also, we can connect to the public network, or we can create our own private Ethereum blockchain. Nowadays, another buzz thing is the blockchain as a service. Microsoft, Azure environment is providing that, and a lot of other environments also providing the blockchain as a service. Again, what is a smart contract? Again, on the Ethereum world, there's a smart contract. There's a program, Solidity program we can use. First, what are the contracts? Small computer program can execute complex contracts physically, right? Can they be broken? Why and how, right? It's a simple, it's a programming language. It's in the database world, we have the triggers, procedures, right? In the blockchain world, I can say a Solidity program, right? Just a comparison between the Ethereum, Bitcoin versus the Ethereum. Yeah, it's a founder is Santoshi, here Vitalik. And Genesis block, first block is mine. He's a pre-sale. Ethereum is always on the ICM and the pre-sale stuff. Blockchain uses the proof of work, and Ethereum also uses the proof of work, and pretty soon they're planning to migrate to the proof of stake. Right now, it is in testing. Usage here, digital currency. Here, usage is the smart contracts and the digital currency. And the currency used here is the Santoshi, Bitcoin. In the Ethereum side, it's a Ether. Again, the blocks creation time here is 10 minutes. In the Ethereum side, they improved a lot, like 12 to 14 seconds. And the mining part, again, this is in the Bitcoin world, only the async miners will use it. Now it's GPUs, right? Whether it is scalable on Bitcoin, not now, but in the Ethereum side, yes, it is pretty much scalable. Again, Ethereum has the EVM. When the node, it's like a JVM. Ethereum has a EVM, right? When the node is created, it has a EVM specification, right? And it has memory area, stacks, and single engine. Again, just a blockchain capacity, right? Visa, we all know. Just I'm comparing against the typical transaction processor or the network. PayPal, 155 per second. Ethereum in 2017 is 100. 2016 is 15. Bitcoin's still 5 to 6. Okay. Yeah, I mean, I have some more to cover, but I think the time is up. I'll pass it to the next speaker.